What's up, everybody? Today I want to show you how to use the spherical Lithophane design tool in Lithophane Maker Desktop. So here we are. This is the screen that you see when you start Lithophane Maker Desktop. The way to get to the spherical Lithophane Maker tool is to go to Lithophanes and come down here to the bottom and click Sphere. Okay? So we have a spherical Lithophane right here, and I'll start off in the top right up here. We have the image editing box right here and then some thumbnails. The first thing that you need to do is to select your images. So I'm going to click there, or I could also click on any of these thumbnails, and I'm going to select some images. Okay, so I have my images selected now, and I need to crop them. Inside of the image editing window, there's a crop box that you can grab and drag. So I'm just going to grab it and crop these images like so. Right now I'm in free-form crop mode, so I can make the aspect ratio of these images anything that I want it to be. It could be, you know, like that if I wanted it to, but obviously this is better, okay? So you can also drag the box around. You can do anything that you want with the box when it's in free-form crop box mode. Now, the next group of settings are image editing settings, and these will adjust the images one by one, so you can adjust the contrast to make the brights brighter and the darks darker. I like the way that they are right now, so I'm not going to do that for any of these. You can do the same thing with brightness, where you make the brights brighter and the darks brighter and everything brighter, or you can make everything darker by making the brightness less, right? So the next set of options are the thumbnails, and the thumbnails have these rotation tools. If I want to activate this picture, I click on the thumbnail of that picture. I can get rid of this picture and select another one by clicking the X and then clicking on the picture, or I can simply pick the picture after it's been picked. Or, you know, click on the picture again, and then I can select a new picture for it, but I like this picture. I can rotate the picture if the picture loads in rotated. And if I do that, then I have to readjust the crop box afterwards, because, you know, once you rotate the picture, it kind of messes up the crop box anyways. So that is that section. The next section has some other options for you. You can make it so that the crop box is freeform like it is right here where there's a check mark. If you click on that, then the crop box is no longer freeform. Its aspect ratio will be forced to whatever works for the image angular height and width that you have. So by clicking this, I open up the angular height as something I can control, but unfortunately that makes my control over the crop box go away. So if I adjust the angular height, then all of the crop boxes are adjusted to the same aspect ratio, and I'm just stuck with it because of the angular height. I prefer the freeform crop box, so I'm going to click that, and I'm going to, you know, recrop everything so that it's the way I want it to be. Get it back to how it was. Those were pretty good. And then finally there's the moon background in this section, which is something that, you know, people love. And you can see that because these pictures have a transparent background, the moon background goes all the way up to the people's faces and bodies. The moon background shows through the transparent parts of these pictures, so you can have that cool effect there. Next are all of the Lithophane, the spherical Lithophane adjustment options. So first we have the Lithophane viewing resolution, and by the way, every single one of these has a tooltip that shows up when you hover over it, and it'll describe what the thing is. Right now that tooltip is going off the screen because I have a wide monitor and I'm not actually showing you my entire screen, but it'll stay on the screen for you anyways. So these all describe how everything works, and you can use those without watching this video, and that might help you a little bit. You can make it so that the Lithophane that you see while you're designing the Lithophane is sharper by making the Lithophane viewing resolution finer, or you can make the lithophane be created faster by making the lithophane viewing resolution coarser. So, if you don't want to wait for the lithophane to update, then you can adjust this to be a bigger number, and it updates faster. My computer works pretty well when it's about 0.5, so I'm just going to keep it at that. And then here's the lithophane resolution that is used for the lithophane that you actually create and save. So this is the resolution of the lithophane that you will print. 0.25 is pretty good. That's really better than most printers can print anyways, so it won't be the limiting factor if it's 0.25. You can make this number smaller, but then the issue that you could run into is that the file becomes really big and your computer might have trouble with the file in the slicer. Once a file gets over 100 megabytes, then people start to have trouble with it in their slicers. So the next setting is the minimum thickness. That sets the thickness at the brightest points in the lithophane. So a value of 0.7 is a good idea, I think. Same thing for the max thickness. It just sets the thickness at the darkest points in the lithophane. So, the lithophane becomes thicker in those areas so that less light gets through. Both of these values work well for American Filament's Lithophane PLA, which I helped develop and have some stake in. Disclaimer. So I set these as the default. You can change them to anything that you want. I would warn you, though, if you make the minimum thickness too small, then it may become really difficult to print. You think about it, your nozzle's diameter on your 3D printer's probably 0.4 millimeters. That's typical. And at 0.7 millimeters, that's not even two nozzle diameters. So your nozzle or your 3D printer already has to choke back the flow a little bit to reach a 0.7 millimeter thickness if it's going to use two passes to get that thickness, which would be a good thing if you use two passes, because it just becomes difficult for your 3D printer to actually print the lithophane and it look good if you use a minimum thickness that is too thin. Okay, so the maximum thickness, if you make this too big, then unless your light is really, really bright, lots of the lithophane will look black or just not even be see-through at all. It might look white if you have an ambient light on, like a ceiling light or something. So this is the ballpark. This is in the ballpark of the right settings. It just depends on which filament you use. This is good for American Filament's PLA lithophane collection. So the next setting is the sphere diameter. This is the maximum diameter of the sphere. You would get this diameter if there were points on opposite sides of the sphere that are both at maximum darkness, so they're the maximum thickness. So, the sphere's surface is actually not a perfect sphere. It's bumpy, and this is the maximum diameter. So if you have a printer that has a build plate of 20 or 200 by 200 millimeters, you could set this to 200, and it should be able to fit on your build plate, assuming that it's the build plate is actually 200 by 200 millimeters, not 200 by 200 minus 5 millimeters margin that they throw in there. Or, you know how that goes sometimes with some printers. So I would set that to whatever you want. I like 140 is good. I mean, you can see what it's going to look like. So it's I think that's a pretty good size, a little under 6 inches. So the next set of settings, just to find how big the pictures are, how much space they take up. Of course, the angular width would max out at 360 degrees because that's the circumference of a circle, and the angular height maxes out at whatever the angle is from here to here, the angle of that arc from this point all the way to the top. And you can just use this to adjust the size of those pictures. I should say also that fit to sphere, what it does is it gives every single picture the same aspect ratio and makes it so that the pictures take up all of the sphere that is available. And I'm not going to click that button because it'll mess up my cropping. And, you know, for this picture, it'll make the kids look like cone heads as their head starts to get warped. I'll show you what that looks like. Their head starts to get warped as it gets closer to the top. There's nothing I can do about this warping. You know, it's just like projecting a rectangular map of the world to a globe. A globe does not project to a rectangle like these pictures perfectly. It's just, you know, geometrically impossible. So I'm going to change that back to like 180-ish because I figured we're going to view this from pretty much one side of the sphere. So, you know, 180 is a good value, but you can do anything you want. The border between images sets the spacing between the two images, or between any two images, and it's in millimeters, so it's the circumference. It's that length of the circumference right there. You can make this number big, and it spaces them out. Of course, they have to become shorter because they have a fixed angular width. So now, because some of that width is going to the spacing, and with also having the fixed aspect ratios of the pictures themselves become shorter. But, you know, you can adjust it pretty much any way you want. And, you know, you could type in here any number that you want. Of course, some numbers are going to be physically impossible. For example, you couldn't pick a number that is bigger than the total circumference of this sphere. And there are ways to break it. I mean, there's some numbers. If I give you lots of flexibility to adjust numbers, then some people will find a way to put in physically impossible numbers. I absolutely guarantee it. But people want the flexibility, so here it is. And at some point, the number caused me to go past some limit, and it automatically adjusted and corrected for that. But, you know, actually, I think I like this around 200. And so the next setting is the top hole diameter. So if you want there to be a hole at the top for one reason or another, then you can get that hole at the top. Maybe you just want a regular hole. What you can do is you can have a hole at the top and then get rid of the cylinder at the bottom, which I'll show you in a second. And then you just have a nice hole that you can put your pictures in. You can rotate them upside down, and you can basically just invert the whole thing. The possibilities are pretty wide. So this hole diameter is the diameter at the inside here. So it tells you the size of a thing that you could shove in here. It's not the larger diameter when you're looking down. It is the inner diameter. So if you have something that you want to shove in there that's 50 millimeters in diameter, you'd make it 50, and you know, you probably would want to add some clearance. So if you had a 50 millimeter diameter thing, you'd probably want that to be like 51 millimeters. And then it could fit in here. For this picture, I don't really want a hole to be at the top, so I'm just getting rid of it. The next collection of settings is for the cylinder at the bottom, so I can get rid of the cylinder. If I do that, then I can't have a base because the cylinder interfaces to the base. And you can see that my pictures here have shifted down for that. But I'm going to keep that so that I can show you the other settings, which allow you to adjust the dimensions of this cylinder. So I can make the outer diameter larger, smaller. I can adjust the cylinder height. I can adjust the thickness of the cylinder, which then affects the inner diameter. You know, you can zoom in here and like look at it from the inside, so I'll do that so that you can see me adjust the thickness. But I like 4 millimeters. And then also you can adjust the diameter of this base here, which is from this side to that side. So you can make it be a really wide base, or you know, whatever you want it to be. I got it at 75. Also, I don't like the cylinder height being too much because it's just sort of wasted space there, so I might make that 10. And now it's a fairly squat cylinder. Might even make it 5. So it's just a little bit more than the thickness part. So those are all of the settings that you can adjust for the bottom cylinder. Now we have this light base model, which interfaces well with light bases that you can find wherever they exist. I mean, it's a pretty common light base. Let me try to get this in the picture here. So you can see it has a shaft for the light, and it has this disc base. And this model is designed to interface with a light fixture like that. The important things are that you make sure that the inner diameter of the light base is larger than the outer diameter of the disc, or else it won't be able to slide on top of it. I have put into all of these settings defaults that will work with a light base that is at this link. Now, I don't know that this link is going to stay good indefinitely, but you can make adjustments as needed. The way that I have put the settings in, it's a little bit snug, so when you put the light fixture into the light base, it'll hold itself in after you're done. But you can also get it out, you know, fairly easily. So there's a little bit of friction there, and then you can see that the light goes out of this little hole. I have little slots in case you have a feature like I have here, where there are these little screws that poke out of the side of the light fixture, and that allows those screws to go up and down without causing an issue. So if you were to adjust some parts of the light base, probably the most interesting one for you to adjust would be the overhang angle, which is the angle of this part right here. So if you're comfortable printing with a 60-degree overhang angle, which many people are, you know, some printers, especially the faster ones, have trouble with that level of an overhang because I guess there's not enough time for it to cool or something, but they just don't print as well at steeper overhang angles. But you can make the base squatter by making the overhang angle larger, right? You can even go all the way up to 90 degrees. I like 60 degrees, so I'm just going to keep it there. Actually, I think I'm going to go to 55 just to give me a little bit of a hedge, because I do have a faster machine. The shaft diameter is right here. So let me just show you what happens if I adjust the shaft diameter. I'll make it a little bit larger, and the spot there where the shaft is supposed to go in became larger. So if you have a light fixture that has a larger diameter shaft, then you need to adjust this to whatever works with your light fixture. Now the base thickness, you can easily see, it's just the thickness of that base there. You know, like 5 millimeters is sufficient, I think. That's pretty strong. It's just whatever you want. The wall height, the base wall height, is the distance from here to here. So for me, that needs to be bigger than this height right here in order for this light fixture to slide into that and be fully covered. Okay, what else do we have? We have the hole width and height. So, you know, great thing is you can just play with these and see what happens. So I play with this, and you can see that this little hole that's there for the cable, that becomes wider if you make this the width bigger, and it also becomes thinner if you make it thinner. 20 works well with the light fixture that I have at this link here. And then you have the whole height, which is, of course, just the height of the hole there. So you can do different things with these numbers. You know, every time that I make a tool, people start using it in some weird way.
Obviously, don't go and do that, please.
Hey, you do whatever you like.
We can't condone anything of the sort.
No, we can't. Live!
Where it's not like my intended use, but they figure out some way to extend the use of it to new and different things. So these are the levers that you have when designing a lithophane sphere. And so now let me show you what happens when you save the STL. You come down here, you click Save STL, and the lithophane will update to the lithophane resolution. You see it just became sharper. And now the STL is saving. It automatically opens up the folder that the STL was saved into. And in that folder you get the pictures that you used. You get the settings file that can be loaded back into Lithophane Maker Desktop by going to Load Settings. It's essentially the same as loading a project. And you get, again, your STL models. So this is the model of the base, the black base here that goes with the lithophane light fixture. And then here is the spherical lithophane model. You can just drop those into your slicer and slice them, obviously print them. The base can be printed in any color you want. The lithophane should probably be printed in using a filament that is good for lithophanes. I recommend American Filament's lithophane PLA. You can see that the size of the model is 125 megabytes. That's pretty big for a slicer to handle, and that's just how it is. There's a lot of detail in this STL. I can't get it any smaller. There's just that many floating points, and that many floating points turns into that many bytes of data. So you just, throw these into your slicer and slice them. When slicing, you definitely want to make sure that your lithophane is solid. You don't want there to be any infill on the lithophane surface. That would be a problem. On the cylinder, you could have infill, and that's fine. You probably want to print it fairly slowly compared to, say, this base right here. This base you could probably print faster, and it'd be okay. But it all just depends on your printer. You can watch some of my other tutorials to get a better idea of what settings are best for slicers. But if you have any questions, feel free to drop them in the comments.